Hi and welcome to this On Maths prediction for the OCR Paper 4 Higher Tier Maths GCSE November 2020. Enjoy! Hi and welcome to this On Maths prediction for the Maths GCSE November 2020 series. So this is a really strange year, as I'm sure you're aware, that we haven't had a GCSE paper in the summer. This paper will be the first GCSE paper almost all of you will have sat, with the exception being Year 13 students who are resitting the Maths GCSE. So it's really, really important that you are prepared, both in your knowledge of the subject and just to your knowledge about how the exam works. And this is what this prediction is supposed to be used for. Please don't 100% rely on this prediction. First of all, the accuracy has been good in the past, but it's never 100%. There's always topics that are not predicted that come up in the actual paper. So make sure you do your revision. What some students do is they do this test now, see how far they can go with it, go off and revise, and then do the test later on to see whether they've improved their marks. And the way they can do that is, you can do it too, is if you go to onmaths.com, you can try this paper online for free. The numbers change each time, so you're not just remembering answers, you actually have to work them out. And it will give you a grade as you go along on the paper, just like this video. So you'll see exactly what grade you are at each point of the paper. We've got loads and loads of other stuff on the website. I'm not going to go into it, but there's loads and loads of stuff that you can also do. And if you click up here, which I think is there, it will take you straight through to the correct paper, so you can just get started straight away. If you want to sit back and just watch how to do the questions, feel free. If you want to give that a go first and then come back to this video, there's a link to this video in the actual GCSE paper on our site. Without further ado, I should say everything is completely free. You are not charged for anything on onmaths.com. So, let's get started. Okay, so we're given three of the kinematic formula or SUVAT equations, and we're asked to use them to answer this question, but it's not going to tell us which one to use. So it says a toy car is travelling at 13 meters per second. So the initial velocity is going to be 13. So we've got the initial velocity because it's travelling at that speed or velocity. It then accelerates at 6 meters per second. So we're given the acceleration is 6 meters per second for 15 seconds. So we're given the time is 15 seconds. Okay, use the correct formula to work out the final velocity. So we're asked to find out what the final velocity is, which is this one. So there's no mention about displacement, which is just a posh way of saying distance with a vector. So we can ignore any equations with s in it. So we can ignore that one, we can ignore that one. So it's going to be the top one. So we're going to use v equals u plus at. I'm just going to scroll down. So v equals u, which is 13, plus a times t. So we're going to put that into the calculator. 13 plus 6 times 15, and it gives us 103. So it's going to be 103 meters per second. So for this question, we just need to remember the area of a circle. Now the area of a circle is going to be pi r squared. Now that's the area for a full circle, my dodgy circle there, but we only have a quarter of it. Now if you have a look, that length there, the 22 centimeters, is going to be the radius of a full circle if I drew the circle properly. So we know what the radius is, and all we do is we times it by the fraction of the circle we have, which is going to be a quarter. So it's going to be pi times r, which is 22 squared, times a quarter. So I'm going to do that on my calculator. Pi times 22 squared, and then you can press equals and then just divide it by 4. That's the same as timesing it by a quarter. And the answer I get is 380.1327 blah blah blah. And so to 2 decimal places, that's going to be 380.13. These questions are just based on a few rules of indices. The first rule says that if you've got two powers with the same base, which these two do because they're both a, you add the powers. Now if you think about it, a squared is a times a to the power of 6 is a times a times a times a times a times a. So in total we're timesing a by itself 8 times. So it's a to the power of 8. The next rule says if you've got a power inside the bracket and outside the bracket, you times them together. So it's m to the power of 3 times 6, which is m to the power of 18. Now this last one's a little bit more complicated, and I'm going to write it out so I've got a bit of a larger one to play with. Okay, first thing I focus on is the number. Now 55 over 11, so I know that 55 divided by 11 is going to be 5. 55 divided by 11, that's all we've got to do. And the reason we can do that is there's only one term at the top and one term at the bottom. Term is defined by, whether there's a plus or a minus, and there's no pluses or minuses here. Okay, so next one, we've got the r's that we want to divide. So we've got r at the top and an r at the bottom. Now this r at the top is technically r to the power of 1. Now when we do r to the power of 1 divided by r to the power of 8, which I'm going to write out down here so I can show you, you take away the powers. So when you times them, you add the powers. When you divide, you take away the powers. So that's r to the power of minus 7. Okay, now we're left with the s's. And it's the same thing with the s's. This time we're doing s to the power of 15 divided by s to the power of 8. So it's going to be s to the power of 15 take away 8, which is 7. So my answer would be 5 r to the power of minus 7 s to the power of 7. Okay, so we're given the density and we're asked for the mass, and we can work out the volume. So the first thing I'm going to do is just draw my triangle, and it's density, mass at the top, volume at the bottom. So to work out mass, I'm going to do density times the volume. Okay, so we go, first of all, have to work out the volume. And of a cuboid, it's just timesing all the dimensions together, so 33 times 22 times 7. So 33 times 22 times 7 on the calculator, and I get 5,082. And so to work out density, to work out mass even, we're going to do volume, density times volume. So density is 2.1. Let's just check the units, grams per centimeters cubed, so that works. 2.1 times 5,082. So 2.1 times 5,082, and I get 10,672.2. Now check out the unit of mass in the density. It's grams per centimeters cubed. So that's going to be grams. Now be careful because the answer is wanted in kilograms. So I'm going to divide that by 1,000 to get it in kilograms. And it says to 2 decimal places. So it's going to be 10.67. Okay, so we're asked to find the length of the line AB, and the way of doing this is you work out how far across you go and how far up you go, and by doing that you create a right angle triangle. So we go 2 across here, 2 jumps across, and if you don't know that that was 2, let's just do a different method. So to get this other one, 1, 2, 3 jumps up, or you just know that it goes up to 4, down to 1, 4 take away 1 is 3. So it's a right angle triangle with sides 2 and 3, and we're looking for the third one. Now, the one opposite the right angle is going to be labelled as C. These two, it doesn't matter, I'm going to call that A and that B. We use Pythagoras' formula. So A squared plus B squared equals C squared. And A is 2, so 2 squared plus 3 squared, because B is 3, equals C squared. Let's put our lines in. So it's going to be 4 plus 9 equals C squared. 13 equals C squared. Square root both sides, and let's get my calculator. So square root of 13 is 3.6055 blah 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 equals C. So it's 2 decimal places, it's 3.61. Now be careful, sometimes it will say that it's done on centimetre square grid, so you might have a units attached. If you want to put units but it doesn't say any, you can just write 3.61 units. Alright, so we're asked to draw a frequency polygon, and the only error you're going to make with this type of question is figuring out what a frequency polygon is. Now, a frequency polygon is where you put little crosses at the points, and the points lie at the group's midpoint. So we've got our first group 0 to 10, so the midpoint would be 5. Next one is 10 to 20, so that's going to be 15. Then 25, then 35, then 45. So the first one's going to be at 5, and it's going to be 6 high. It's going to be like that. Next one's 15, 22. So 22 would be about there. 25, 59, so 59 would be right up here. 25, 35, 15, a little bit lower than that, but that's fine. 45, 4. Now we're only halfway done, and my points aren't exact because the screen I'm using isn't the most precise, but it's good enough. We're only halfway done because what we need to do is join these up with straight lines. So no curves needed. And when you join them up with straight lines, do not ever join up the last 2 points. You're not actually trying to make a polygon, okay? So don't ever, when you join them up, whatever, right? Don't ever draw this line here, okay? That's not a good thing to do, so make sure you don't do that. Okay, and that's it. So midpoints, crosses, and then join them up with straight lines if you're asked for a frequency polygon. Alright, so it says that the town council is saying that over a quarter of the stores get over 30 customers. So we're going to see whether that's right. So over 30 customers would be these two groups here, so 30 to 40 and 40 to 50. So that is 19 altogether. So that's 19 out of, and let's add all the rest up, so 6 plus 22 plus 59 plus 15 plus 4, out of 106. It didn't say it in the question. So it's 19 out of 106, which as a decimal, 19 over 106 would be 0.179 to 3 decimal places. So what I would say in the exam is no, because that is 17% or 17.9%. So it's less than 25%. And just write a sentence saying that yes, it's close, but it's not quite at 25%, because even rounding up to the nearest percentage, it's 18%, which is 7% lower than 25%. So just make sure you write all of the numbers in an answer that answers the question. For these types of questions, always make sure that you show your working. Show how you know something is something. So the way I would start this, and this is not the only correct answer, is I realise that these two are the same. So I know that 2y minus 50 equals 52. The reason I know that is that they are corresponding angles. Now, some of you might know that as F angles, but make sure you write the word corresponding because they won't accept any other word. So I can solve this by first of all adding 50 to both sides. So that's 2y equals 102, and then I'm going to halve both sides. So y equals 51. So I know y is 51, so I now know that this angle here is 51 degrees. Now I know that this is 52 degrees because if you look at this, and I'll use a different colour, this angle here and this angle here are Z angles or alternate angles, or you can say that this 52 degrees here is equal to this here, which is also 52 because they're vertically opposite angles. So I know that this one here, and I could call it a letter on the diagram, so I could say C. I don't think there's another C, so C equals 52, and show the examiner, right, that's because, well, let's go for alternate angles with the original value. Okay, so we've got three sides, or three angles in a triangle. I've got way too many colours going on here. So to work out x, so x equals, it's going to be 180 minus 51 plus 52. So work out what 51 plus 52 is, and then take away from 180. And the reason is angles in triangle. Okay, so I know that 51 plus 52 is going to be 103. Therefore that's going to be 77 degrees. So my answer is 77 degrees. Okay, so I'm asked to complete the Venn diagram, and the E at the top I like to think stands for everything. So all of those numbers need to fit somewhere in this Venn diagram. And we're going to put the square numbers on the left and the odd numbers on the right. Now there's different methods of doing this. What I like to do with this type of question is just do it one at a time. So we're going to start off with the 16. Now 16 is a square number, but it's not odd. So I'm going to leave that here. 75. Now 75 is not a square number, but it is odd. So I'm going to put that there. Now 1 is a square number and it's odd, so that's going to go in the middle. 4 is a square number but it's not odd. 28. Now 28 is not a square number and it's not odd, so that's going to go out here. 9 is a square number and it's odd, so that's going to go there. 93 is not a square number but it is odd. And 2 is not a square number or odd. That's going to go on the outside here. And I like to just add them up, find out how many numbers we've got in our Venn diagram. So 1, 2, 3, 4, 5, 6, 7, 8. And find out how many numbers we should have. 1, 2, 3, 4, 5, 6, 7, 8. So we haven't missed any, because it's quite easy with this type of question to miss a number out. Okay, so we're asked to write 88 as a product of its prime factors. So the first thing to do is write 88. And then we have two shoots coming from it. Now I need to find out which two numbers times together to make 88. Now a little tip, if you've got an even number, always pick 2. So 2 times 44. Now whenever we get to a prime number, we always circle it, because that's finished. So 44, I can get another 2 out of that, we'll divide another 2 out of that, so 2 and 22, 2 and 11. Now 11 is also a prime number, and when you're left with just prime numbers, then you write your answer out like this. Now if you're also asked to write it in index form, that means instead of 2 times 2 times 2, you're going to write 2 to the power of 3 times 11. Now don't work that out, because that will give you 88, so 2 cubed times 11 is 88. Okay, to convert from standard form, you just write the number down, and this here, the power, will tell you where to go. So if the power is positive, then you go to the right. If it's negative, then you jump to the left. Now since it's negative, we're going to jump to the left, and it's -6, so we're going to jump 6 spaces. So 1, 2, 3, 4, 5, and 6. So the decimal point will now be here, and you fill in all of the jumps with zeros. So one of the jumps is used by the 8, but all the other ones we fill in with zeros. And whenever you've got just a decimal point, you need to have something before it, so we put a 0 before it. So the answer will be 0.00000084. That would be the answer. So let's just count. There's 5 zeros and 5 zeros. Okay, to convert to standard form, you write out the number, and you try and put a decimal place in to make the number between 1 and 10, but not including 10. So if I put it in here, that would be 72, so that would not be right. So I need to put it in here. Then you count how many times you had to move the decimal point to get it there. So the decimal point started at the end of the number, and we had to move it 1, 2, 3, 4, 5, 6. Okay, so the rule is that the number has to be between 1 and 10, which this one is. Now, if you had a big number, then the power of 10 will be positive. Now here we did have a big number, so it's going to be +6. On the previous one, we had a small number, 0.00084. I don't know if I said the amount of noughts that were there, and you can see that the power in the question was negative. So negative power of 10 is really small number, positive power of 10, really big number. This does turn up on the calculator paper as well. So if it does, you can actually just type in question A into your calculator and just write down the number it gives you. Now some calculators are smart and do things in standard form, so you might need to do it this method anyway. Okay, with this question, the first thing to realise is that we have two similar triangles here. So we've got the smaller triangle here, and we've got the bigger triangle here. And they are mathematically similar because this angle is going to be the same as this angle, because they're parallel lines, those are corresponding angles. This angle is going to be the same as this angle for the same reason, and this is a shared angle. So there are two triangles with exactly the same angles, therefore they have to be mathematically similar. And mathematically similar means all the angles are the same, but we've just multiplied all the lengths by something to get to the new triangle. So, important first step of this is to draw out the two triangles. Okay, and I'm just going to sketch them out roughly. So a small one, and we've got the big one. And then copy the length. So this is going to be 23, this is going to be 9, this is going to be 36 at the bottom here, and this one's going to be 60. Okay, now ask for the value of CE, which is this bottom length here. That's the bit we're trying to find. But I'm going to ignore that, and I'm going to work out what AC is. The reason for that is if I know AC, I can take away from 60 to work out CE, because I know the total distance is 60. Okay, to do that, I need to work out what the scale factor is. And the scale factor, all you need is a length on both of the triangles, which is corresponding, which means it's the same length, but on the two different triangles. And to do that, we do the big length. I say the same, it's not going to be the same length, but the same position on both triangles. So big length over small length. Okay, so the two I'm going to pick is obviously the bottom two. And we're going to find out what we times 9 by to get to 36. So 36 over 9. And that's obviously going to be 4. Okay, because 4 times 9 is 36. Okay, so we know we times that by 4, so the scale factor is 4. Now, if we go from big to small, we times it by 4. But here, we're going from, if we go from small to big, we times it by 4. But here we're going from big to small. So instead of times by 4, we're going to divide it by 4, because it's going to get smaller, isn't it? So we're going to do 60 divided by 4, and I should really write down what I'm doing. I'm doing AC, and that's going to be 15. So we know that it's going to be 15 here for this bit, okay? But the total is 60, and we're looking for what's left over. So we're going to do CE equals the total 60, take away the bit we know that we don't want, and that's going to be 45. So the answer is 45. Okay, so we've got an athlete and 2 hurdles, and if he jumps the first one, the probability of him jumping the second one will change. So it's a conditional question, and we're asked what's the probability he will hit one hurdle. Now, one hurdle does not mean 2 hurdles. One hurdle means exactly one hurdle, so you've got to be careful with the question. Okay, so we start here, and if he jumps the first one, then we're looking at him hitting the second one, because he has to hit a hurdle. So we're looking at him hitting the second one. If, however, he hits the first one, he can't hit the second one, otherwise we'll end up hitting 2 hurdles, and it says it will hit 1 hurdle. So he has to jump the second one. So he's either going to hit the first one or the second one. Okay, what we need to do next is work out the probabilities he will jump the first one, then hit the second one. So we just get the 2 fractions and times them together. So that would be 4 over 70. No need to cancel at this point. Okay, and let's work out the probability you hit the first one and then jump the second one. So that's 3 over 7 times 10 over 13. So that's going to be 30, and then I could do this in the calculator or just do it in my head, over 91. Okay, now we're either going to end up here where he's hit the second one, or here where he's hit the first one. The word or in probability means add. So he's either going to hit the second one, or, which in probability is add, hit the first one. So on the calculator, because this is a calculator question, so it'd be 4 over 70 plus 30 over 91. So that's going to be 176 over 455, and let the calculator do the hard work there. Now, if it's a non-calculator question, generally speaking, the denominators of the fraction are a little bit simpler, and they tend to do those on the independent ones because they can manipulate the denominators a little bit more. Okay, I'm just going to write this out to make it a bit bigger. Now we're asked to make A the subject, which means we want A equals. So I'm going to put my lines down. Now the first thing I need to do is get rid of that square root, because if you look, the right hand side is all trapped in that square root. So what I'm going to do is square both sides. So we've got t squared equals, and when I square the square root, it just gets rid of the square root. Okay, next I need to get rid of that 3, so I'm going to take away 3 from both sides. So we've got t squared minus 3 equals 10a. Then I'm going to get rid of that 10. Now that's a times 10 there, so I need to divide both sides by 10. Now I could divide the t squared by 10 and the 3 by 10, or I can just write it as a fraction, which is a lot easier. So just put the whole thing over 10. So therefore a equals t squared minus 3 over 10. Now it's really important that if the letters are capitals, we keep them as capitals. If they're lowercase, we keep them as lowercase. It does matter what case the letters are, so if it's uppercase or lowercase. Whenever we see a 3D shape in a question, you've got to ask yourself, is the question asking for a volume or a surface area? And that should be the first question that goes into your mind. Yes, it might be asking for something else, but those are the main two. We're looking at this, we're filling the swimming pool with water, so it's going to be a volume question. Now, way of approaching this is figure out what the shape is. Well, the shape is a trapezium-based prism. So we've got to first of all work out what the area of the trapezium is. So I'm going to draw the trapezium out first. And that height is going to be 2.7 that side.
5.3 that side, and 25 across. And I'll leave off meters because I know they're all in meters, but do check they are all in meters when you do this. So we've got so first of all work out the area. Now the area of a trapezium is half A plus B H. Now A and B are always the two parallel sides, and then the height is the one that connects them at right angles. So the height is going to be 25 there. And all you're doing is working out the average of the two bases, the 2.7 and the 5.3. We're going to times that by 25. Okay, so we'll crack our calculator out. 2.7. Some of you will probably see this straight away. So the first bit comes out as 4, because halfway between 2.7 and 5.3 is 4, and then times 25 is going to be 100. So the area is 100 meters squared. Now, for a prism, so volume, all you need to do is work out the area of the cross section, which is this bit here, the bit we just worked out, and then times it by how 3D it is. I think they call that the length officially, 15 meters. So the volume is going to be 100 meters squared times 15, which is going to be 1,500 meters cubed. So that's what the volume is, and it says the machine transports the water at a rate of 20 meters cubed per minute. So in 1 minute it's going to be 20, in 2 minutes 40. The other way of working this out, or the other way of thinking about this, is how many 20s are there in 1,500? So we can say time equals, so this is how much it's got to fill, and this is how much it does per minute. So on the calculator, 1,500 divided by 20, which equals 75 minutes. So it's going to take 75 minutes to fill the pool. The easiest way I've found to work with bounds is just draw a number line, put the number that you've got, so we're looking at x, put the number you've got in the middle, try and figure out what the next number down would be. So the next number down would be 1.1 if they're rounded to the nearest one decimal place. What's the next number up? Well, it would be 1.3. So the next thing to ask yourself is, where's the cutoff point? What stopped it from being 1.1? Why did it round to 1.2? So the lowest it could be is halfway between those two numbers, which is 1.15. So that is our lowest bound, lower bound. The upper bound, the higher bound, would be here, which would be 1.25, but we're not asked for that. So 1.15 is the cutoff point. Now this is a slightly harder question in B because we're given this formula here. Now we've got to be careful when we're using formulas. We're looking for the upper bound of t, so we're looking for t to be as big as possible. Well, for t to be as big as possible, x needs to be as big as possible because we're adding it and we want a number to be big that we're adding. But the bigger y is, the smaller that fraction becomes. So we want actually y to be as small as possible. If you ever think about it, the fraction a half and the fraction a third, which is bigger? Well, a half is bigger. So the smaller the number at the bottom, the bigger the fraction. Anyway, a little bit of a side note, but that's really important that you remember that if there's a denominator, that we want it as big as possible to make the smallest possible number, or as small as possible in this situation to make the number as big as possible. So we need to find the upper bound for x and the lower bound for y. So using the diagram I drew earlier, 1.25 is the upper bound. Now you might say to yourself, well hang on, no, technically 1.25 would round to 1.3. Okay, let's delve into that a little bit. The actual answer should be 1.249 recurring, but there's two reasons I've not written that. The first reason is that it's a pain to work with. Typing that into the calculator would be a pain. The second thing is that actually 1.249 recurring is the same as 1.25. They are exactly the same number. Now, if you don't believe me, a little bit of a side note, a third is 0.3 recurring, 2/3 is 0.6 recurring. Following the same pattern, 3/3 would be 0.9 recurring. But we know 3/3 is the same as 1. So 0.9 recurring is the same as 1. There is no difference, and that's very difficult to get your head around. Anyway, side note over. So the upper bound of x is 1.25. So we need to do a little number line to get the lower bound of y. So it's 4.6. So the next one down would be 4.5. So the cutoff point is going to be halfway, which is going to be 4.55. So that's going to be our lower bound, 4.55. So to find the upper bound of t, we need to do 1.25 plus 1 over 4.55. So let's just do that on the calculator. 1.25 plus fraction button 1 over 4.55. And I get the answer 1.46978 blah blah blah. It says it wants it to 2 decimal places, so it's going to be 1.47 because that 9 would round that 6 up. Okay, so we're asked to rearrange this formula, and I'm just going to write it out again so that I've got a bit of space to work in. Now, we want to make W the subject, which means we want to get W equals and then whatever it equals. So the first thing I'm going to do, well, we could times all 3 terms by 7, but students often forget to times all 3 terms by 7. So we're going to focus on the 91. We're going to take away 91 from both sides. That leaves us with a minus 91 on the left-hand side, and then this fraction on the right-hand side. Now we want to get rid of that fraction, so to do that we're going to times both sides by 7. Now I could write 7a minus whatever 91 times 7 is, or I could just leave it in a bracket, and that's absolutely fine. Now I'm just going to switch this around. In fact, I might switch this around and continue working up here, so I've got a bit more space. And I haven't actually changed anything, I've just switched the equation around the other way. So I've got the W on the left hand side, and last thing I'm going to do is divide by 4 both sides. So W, because we've got rid of that 4 by dividing it, and I can write this as a fraction, so I just leave it all of that over 4, and that's absolutely acceptable. In fact, that's the only way we can write that, because we can't cancel the 7 and the 4. Now, if you expanded the brackets, that would be absolutely fine. You'd still get the right answer. It's just I don't really want to times 7 by 91 if I don't have to. Now, this is a question about composite functions, and I'm going to start this question off by just answering this question. What is f bracket 4? Now, this equation here, up until this level, that used to be y equals 4x, and the question we have here would be what is y when x equals 4? It's the same question, it's just a different way of writing it. So all you need to do for f brackets 4 is feed in 4 as x. So that's going to be 4 times 4, which is 16. Okay, same answer as this, and it's the same question just written differently. And at this level you need to be comfortable with function notation rather than y equals. Okay, now I said I'd ignore the g. The g says, oh okay, when you're done with f, g wants to do it as well. So what I should be writing is this, and I still have to apply a g to all of this. Let's get rid of that. And so I still need to apply the G to the 16. So we've done the F, and the F we did first because it's closest to the brackets. So whichever one's closest to the brackets you do first. Okay, we've done the F. Now we need to do the G, and we just do exactly the same thing. So G of 16, we're going to feed 16 into the equation. Well, it says 7 plus 2x, so it's going to be 7 plus 2 times 16. Well, I know 2 times 16 is 32, and I know 32 plus 7 is going to be 39. 39, okay. And so therefore the answer is just 39. Okay, perfect. Right, the next one. This time it's important to notice that the F and G are the other way around. So it's G that we're going to be doing first and then F. Now the thing we're feeding in is X. Well, you can't feed in X as X. Well, you can. It's just going to remain as X. So let's focus on the G first. So we're going to do G of X first. And now G of X is just given to us in the question. It's this bit here. So it's going to be 7 plus 2x. Now F wants to then use that 7 plus 2x and feed it into the f of x equation. So f of x is 4 times x. We're feeding in the 7 plus 2x, so it's going to be 4 times 7 plus 2x. Then we can expand that a little bit. So 4 times 7 is 28, plus 4 times 2 is 8x. Okay, now there's an equation here which I've kind of ignored up until now, but we need to write it now. So it says that 28 plus 8x, which is the FG brackets x, equals 52. So let's sort that out, solve that. So the first thing I can do is take away 28 both sides. And if it's on the calculator paper, you might as well use a calculator to double check your answer. If it's not on the calculator paper, I think most of you will be able to work that out. It's 24. And then we want to divide the 8. So we get x equals, so it's x equals 3.
Okay, so this is an inverse proportion question. So the first bit I start with for this question is this line here. So as soon as I see that, I just write down b, and this fish symbol, which means is proportional to. The inverse is 1 over, so whenever it says inversely proportional or varies inversely, it's 1 over, and it says the square of a, so I'm just going to write a squared. Now I'm going to get my lines in. Okay, so to get that fish sign to an equal sign, I need to times the right hand side by k, so it becomes k over a squared. Now I'm going to pick a value of a and b. Now a and b are called variables, they're going to change. The k though is a constant. When we find k once, we found k for good. Now looking at these options, I kind of like this one the best. It's kind of simple. I like a nice simple fraction, 1/8 and 8. Okay, I can work with that. So it says b is 1/8, so I'm going to substitute in b is 1/8. And k we are trying to find out, and it says a squared, so it would be 8 squared, which would be 64. So I'm going to times both sides by 64, so I can find what k is. So it becomes 64 over 8 equals k, so therefore k is equal to 64 divided by 8, which is just 8. So putting that back into this equation here, or formula here, becomes this equation here. So b equals 8 over a squared. Okay, I'm going to use that to find out what a is when b is 2. So I'm going to write the same thing as I've written down for my answer here, but instead of b I'm just going to write 2. So 2 equals 8 over a squared. Get my lines down. Okay, so the first thing I'm going to do is times both sides by a squared. So the best thing to do is get rid of any brackets or fractions. and since that means divide, over means divide by a squared, and times by a squared, so it would be 2a squared equals 8. Then I'm going to divide by 2 both sides, so I get the a squared in its own, so it's a squared equals 8 divided by 2 is 4. Then I'm going to square root both sides. So this could be 2 or minus 2, but it does say positive value, so a equals 2. So if I put a as 2 into the answer to question A, it would be 8 over 2 squared, which is 4, so 8 over 4, which is 2, so b equals 2.
Now there's a couple of ways of doing this question. We're asked to complete the table and then complete the histogram. You can do this by counting squares, but I'm just going to use the formula for this. And the formula, choose the right one. The formula has frequency at the top and frequency density and class width at the bottom. And it works the same way as most, or speed, distance, time, and all of those ones. So we know that class width, let's work out the class widths for these. That's going to be 40, that's going to be 40, that's going to be 20. And I'm just looking at the distances between the 80 and the 100, so I'm doing 100 take away 80. So the next one's going to be 40, and the last one is going to be 60. Okay, now I know that I do the frequency divided by the class width to work out the frequency density. So I'm going to do 44 divided by 40. So I'm going to divide that by the class width, which gives me 1.1. Now if I go to my diagram and label that as 1.1, because frequency density is on that axis, on the y-axis, then if I look down, well, I notice that that's going to be 1.0, 0.8, 0.6, 0.4, 0.2 and 0. So it works perfectly, and then obviously 1.2 at the top. So now I know my frequency densities, I can actually work out what the next frequencies are. So the next one has a frequency density of 0.6. So I'm going to times that by 0.6, because this is our frequency densities. Times that by 0.6, so I'm going to do 40 times 0.6, which is 24. The next one has a frequency density of 1.2, looking at the graph, or looking at the histogram, so 1.2. So I do 20 times 1.2, which is 24 as well. Okay, this time I've got to work backwards. So I've given the frequency and I've given the class width. So I need to divide them across, so divide that by 40 and divide that by 60 to work out the frequency densities. So 24 divided by 40 is going to be 0.6, and 36 divided by 60 is going to be 0.6 as well. Well, that's convenient. So they're both 0.6. So the first bar is going to be at 100 to 140, and it's going to be 0.6. So 140 is going to be there. And then the next bar is going to be 140 to 200. So it's a slightly longer bar there. And I'm just putting these off center so you can see them a little bit better. Now you don't need to shade these bars in, just draw them with a pencil and a ruler, and then that's it. Okay, so we're given a velocity time graph and we're asked for the distance or displacement. And to work that out, you simply work out the area underneath the graph. So if I draw a line down here, we've got two simple shapes. We've got a trapezium here and a rectangle here. So we'll tackle the rectangle first. So to work out the area, it's the width, which is 3, times the height, which is 160. And when you do that, you can do it on the calculator if you wish, 480. Okay, A is a little bit harder, it's a trapezium. So the area of a trapezium is half A plus B H. Now H is a bit unusual because H is on its side here. So H is here. And then we've got A and B. It doesn't matter which way around you put them because you're adding them together. So it's going to be half times A plus B. So that's 40 plus what's that, 160, and then times h, which is 2. Now you can see there the half and the times 2 cancel each other out, and so it's 40 plus 160, which is 200. Okay, so the total area is going to be 680. So our answer is 680 meters. Okay, this seems like quite a simple question, but actually it's got quite a few different things we need to do. So first thing I'm going to do is find out the area of the sector. Now the sector is like a slice of pizza, so it's the whole thing. And the way of doing that is you do the angle over 360 times pi r squared, so pi times 10 squared, because 10 is our radius. So I'm going to type that in now into my calculator, so 39 over 360 times by pi times 100, and I'm going to leave it in terms of pi, so 65 over 6 pi. Okay, now next thing I need to do is work out the area of the triangle. Now if I show this triangle, so it's going to be the area of this triangle here. Now it might look like I can't do that. Well, actually I can, because this length here is also 10 centimeters, and we know that there's a formula for working out the area of a triangle with using trigonometry. So area of triangle, and the formula is half AB sine C. Now C is the angle, and A and B are the two lengths either side of it. So half times 10 times 10 times sine 39. I'm going to type that into my calculator. And that is 31.466. 01955. And the reason I write down the numbers is we've got another piece of calculation, so I don't want a rounding error. Okay, so the area of shaded and the area of the shaded bit is going to be the sector area take away the triangle area. Okay, so 65 over 6 pi, take away 31.46. Now I've still got the 31.46, so what I'm going to do is I'm going to type in 65 over 6 pi, and then I'm going to take away answer, because it's still stored in the calculator. Press equals, and it's 2.5679 blah blah blah. And it wants it to 2 decimal places, so that's 2.57. Okay, so this looks like it's a kind of quadratic question, but it looks a bit of a mess. There's a really easy first step to sort this all out, and that's to times everything by y squared. So just times literally everything in the equation by y squared. So 5 over y squared times y squared just leaves 5. And here we've got 7, and in fact I'm going to write this as a fraction still so we can see it a little bit clearer. So we've times that by y squared, but we've not really dealt with it yet. And we've got minus 3y squared equals 0. Now the y at the bottom and one of the y's at the top cancel. So we end up with 5 plus 7y minus 3y squared. And since we'll use the quadratic formula on this, it's probably easier I put it in order. So that would be minus 3y squared plus 7y plus 5 equals 0. So we've got to find out what a, b and c are. A is the number before the y squared, which is minus 3. B is the number before the y, which is 7. And c is the number on its own at the end. Then we're going to use the quadratic formula, okay, which is x equals minus b plus minus square root of b squared minus 4ac over 2a. Okay, so I'm just going to type that all into my calculator. It's a lot easier doing this than going through. I'm going to do plus first, and then I'm going to go back and change that. So minus brackets 4 times minus 3 times 5, close brackets over 2 times minus 3. Press the equals, and I've got an answer of minus 0.57338, blah blah blah. To 2 decimal places, that's minus 0.57. I'm going to go back on my calculator and change that plus to a minus. And it also equals 2.9067, blah blah blah. So that's going to be 2.91 to 2 decimal places. And so the trick with this is just convert it into something y squared plus something y plus something equals 0. Okay, so this question asks us to rearrange this bit to make it in this form here. Now, we're not going to use the bit in red at all in our answer. It's just there as a guide of what we're looking at getting. And this sign here just means is completely equivalent to, so it works for any value of x. So we're going to first of all look at that and go, right, how are we going to get there? Well, this is a completing the square question, so we're going to have to complete the square to get it in that form that I've highlighted in red. Now, to complete the square, we look at this first bit here, and we go, right, how do we create that in a bracket? And to create that, what we do is we put x at the start of the bracket, and we halve the number before the we halve the number before the x, that 10, to make 5. Now, the problem with that is if I expanded that, so x plus 5, and I use FOIL or anything else to expand it, I'll get x squared plus 5x plus 5x, so plus 10x. That's great, that's what we want. But then it has plus 25. So when I expand that, it creates me a 25, which I don't want. So what I'm going to do is I'm going to put the brackets down, and then I'm going to take away 25 because it creates a 25 that I don't want. And then I'm just going to finish it off because it says plus 11. Now that is identical to the bit on the left hand side in the question. Okay, there's no difference. We haven't changed anything. We've just had to take away 25 because that bracket creates a 25. Then we're just going to put it together. And we're going to put the minus 25 and the plus 11 together. So it makes minus 14. So our p-value is the thing inside the bracket, so x plus 5. And our q value is the bit outside the brackets, that's minus 14. This is a question about iteration, and question A is a little bit harder maybe than the exam will go, where it asks you to come up with your own iteration formula. So, in order to do this, it says that fx equals 0 for this formula. So the first step is just to get it equal to 0. Now the question's given you a hint because it says that it involves a cube root. So we know that we're going to have x cubed equals something, and then we're going to cube root both sides. So I'm going to just put my lines down. And we're going to add x and add 5 both sides. And we're just going to cube root both sides. So our iteration formula is going to be the cube root of x plus 5. Now, with the iteration formula, it's a beautifully simple idea that this formula will, as long as we just keep ploughing in what we've found for the answer before, it will get us closer and closer to the real root. Now, sometimes the roots are infinite. So we could be sitting there all day and it will get a closer and closer and closer answer. This is why the question will say, 3 decimal places or 4 decimal places. So that will tell us when to stop. So it always will give you a first one, okay, the x0, the first one to try. And all you're going to be doing is putting that 1 into this formula here. Okay, so let's try it. So cube root of 1 plus 5. And that gets me 1.81712, blah, blah, blah. Okay, now I need to keep that answer. So what I'm going to do is I'm going to press the cube root button. Then I'm going to click inside the root. I'm going to click answer plus 5. And the calculator will remember the answer to the one we had before. Now, if you try and round them, you will get very, very different answers. And it might take you a little bit longer, or you might make a mistake. So you let the calculator do all the remembering for you. Then I press equals, and I get 1.89612, blah, blah, blah. So I'm going to do the same again. So I'm going to do the cube root button, answer plus 5. And we've got 1.9034, blah, blah, blah. Cube root button, answer plus 5. And we've got 1.9040, blah, blah, blah. Now, we're looking for 3 decimal places, so the numbers we're looking for being the same are these ones here. Now, we've almost got them the same, but we're not quite there, so we need to do another one. So cube root, answer plus 5, and we've got 1.9041, blah, blah, blah. Now, even if you were to carry on going, the first digits, the digits I've circled with I've put a red square around, are going to remain the same. So as soon as you get 2 that are the same to 3 decimal places, that is your answer. So my answer is going to be 1.904. Now, obviously we haven't got it perfect, but if you carry on the iteration, you won't ever get anything different to 1.904. The only numbers that will change are beyond that. So that's why we can confidently stop now and say, yes, that's our answer. Okay, so we're asked to solve these simultaneous equations. The one at the bottom is a formula for a circle, but that's of no interest at all. We're just finding out what x and y can be. Okay, there's going to be multiple answers to this. So looking at the first equation, we've got y equals this, 3x plus 11. And in the second one, we've got a y here. So all we need to do is replace that y in the second one with this bit here, and I'm going to put it into brackets. If you don't put it into brackets, you will get the wrong answer, so make sure you put it into brackets. So I'm going to write out that second formula, the second equation, but this time I'm going to put in the 3x plus 11 squared, or 3x plus 11 instead of the y. And now I need to rearrange this so that I've got a nice quadratic. So the first thing I'm going to do is expand that bracket. So I'm going to do, 3x times 3x is 9x. 3x times 11 is 33, plus another 33 is going to be plus 66x. And then 11 times 11 is going to be 121, equals 125. Then I need to subtract, first of all, it's 9x squared, because clearly x times x is x squared. So x squared plus 9x is 10x squared. And we've got the plus 66x plus 121 equals 125. So we need to get rid of that 125, bring that across. So we need it equal to 0 to use the quadratic formula. So 10x squared plus 66x, and what's that? It's going to be minus 4, isn't it? Okay, now we've got a quadratic equation. So we've got a equals 10, b equals 66, and c equals 4. So we need to know the quadratic formula, which is minus b plus minus square root of b squared minus 4ac over 2a. Okay, so what you can do is just use your calculator to do this. Press the fraction button first. We're going to do the minus 66 because b is 66, and we're going to type in plus square root button, and what is it, 66 squared minus 4 times 10 times minus 4. Then click the down button, 2 times 10. I'm just going to press equals, and that gives me 0.06 to 2 decimal places. But I'm going to leave that in my calculator because what I'm going to do is I'm going to look at this equation. It tells me how to find y. It says y is 3x plus 11. So y equals 3x plus 11. So what I'm going to do is just times that by 3 and then plus 11. So that gives me 11.18 to 2 decimal places. So there's my first two solutions, 0.06 and 11.18. Then I'm going to see if I can go back. Does my calculator let me go back in time? No, it doesn't. So I'm going to have to press the fraction button again, type this all out. So minus 66, and this time take away square root button, 66 squared minus 4 times 10 times minus 4 over 2 times 10. I could just write 20, but anyway. Okay, this time it gives me a value of minus 6.66. And again, I'm going to find out the y by timesing it by 3 and adding 11. So I'm going to times that by 3 whilst it's still in my calculator, and I've still got all the accuracy, plus 11, and it gives me minus 8.98. So my other two solutions are minus 6.66 and minus 8.98. And you could try and write down some estimated values for the marker in case you've made a mistake on the calculator. Try and write down as much as you can write down so you get marks even if you've got the wrong answer.
Okay, so this doesn't seem like the easiest questions because there's 3 shapes going on. There's no numbers in it at all, and we're asked to find a formula. So the first place I'd start is working out, well, first of all, what are the formulas we'll need? Well, let's have a look. So we've got a hemisphere. And some of these formulas you will be given. So a hemisphere is a volume of a sphere and then halved. So instead of 4 over 3, I can just say 2 over 3, which is half of 4 over 3, pi r cubed. The cone that we've got is going to be 1/3 pi r squared h. And then the cylinder we have is the area of the circle times the height. Okay, now we need to find out what the bits are. So for the hemisphere we just need r. Well, that's quite simple because r is just going to be x. It's the radius of the hemisphere. Okay, now what's more difficult is to work out the height of the cone. Well, if the radius across to the right is x, the radius of the circle up is also going to be x. So we know the height of the cone is going to be 4x because one of those x's is used on the hemisphere. We know the radius of the cone is going to be x because it's stated at the top. So let's keep going. The radius of the cylinder is going to be 10x, and the height is just labelled as h. So that's nice and simple. Okay, now let's have a look at what this question's saying. It's saying that this thing here
is going to be melted down and is going to be used to create this. So that's just saying that the volumes are going to be the same. So if I add the volume of the hemisphere to the volume of the cone, it should equal the volume of the cylinder. Okay, so we know that hemisphere plus the cone volume, and I should write volume here, show the examiner that I'm working with volumes, equals the volume of, I don't know why I wrote an S, my goodness, C for cylinder. Wow. Tell my maths teacher, right, cylinder, there we go. So hemisphere is 2/3 pi, and we said that x was the radius, so x cubed. Brilliant. So plus the cone. Now, what did we say the height of the cone was? We said the height of the cone was 4x. So it's going to be 1/3 pi x squared, because the radius is x, and is it 4x? Let's double check that. Always double check. Yeah, it is. Okay. So the cylinder, and I'm going to leave that up so I can see it, is pi, and what's the r? So pi times 10x squared, and all of that squared, because all of that is r, times the height, so times h. Okay, so this is the formula we've got to work with. I'll put my lines down. Okay, so what we got? Let's sort out the timeses first, and let's tidy this up. So that hasn't got any timeses in it. This we're timesing it by 4, so it's going to be 4/3 pi, and I'm timesing it by x, so that's going to be x cubed. This one, I'm doing the 10x squared, so I need to square the 10 and the x, so it's going to be 100. And let's do the pi next. Pi, and it's going to be x squared h. Okay. Now, if you notice on the left-hand side, these two here are the same. There's both pi x cubed. So we can just add them together. So it's going to be 2/3 plus 4/3. So that's going to be 6/3, or just 2. So it's going to be 2 pi x cubed equals 100 pi x squared h. Brilliant. Okay. Now let's just check to see what it wants. It wants a formula of h in terms of x. So it wants h equals. Okay. So first thing I need to do, well, let's have a look. What's easy to do? Well, what's easy to do is just divide both sides by pi. Let's get rid of the pi's. So 2x cubed equals 100 x squared h. Now we want h on its own, so we're getting close. We need to divide by the x squared first to get h on its own. So I'm going to divide by x squared. So we get 2x equals 100h. So we can already see we're really close. So to get h on its own, we need to divide both sides by 100. And that's going to be 2x over 100 equals h, or h equals, and we can cancel the 2 and the 100. We can divide them both by 2. Equals x over 50. So our answer is h equals x over 50. Okay, so we're asked to find the nth term of the sequence. So the first thing I need to do is work out what the sequence is going up in. So 9 to 22 will be 13. 22 to 41 would be 19. It's not the same. Okay, so that will be 25, and then this will be 31. Okay, so whenever you have a sequence that's not going up by the same amount, then the next step is to work out what the differences are going up in the difference of the differences. Well, that's 6, and this one's 6, and this one's also 6. So if the difference of the differences is always the same, then you've got yourself a quadratic sequence. And the way of dealing with that is get the difference of the differences and always halve it. Okay, so we end up with 3. Now that 3 will go before an n squared. So we know our nth term will involve 3n squared, but we don't know what the rest of it is yet. So what we do is a little table, and we write in our sequence, which is 9, 22, 41, 66, and 97. And then we write down the sequence for 3n squared, which is going to be 1 squared times 3, okay, because n is 1 for the first term. So that's going to be 3. 2 squared is 4 times 3 is 12. N is 3 for the third term, so 3 squared is 9 times 3 is 27. N is 4 for the fourth term, so 4 squared 16 times 3 is going to be 48. And then 5 squared times 3 is going to be 75. Now what we want to do is take 3n squared out of our sequence. So if I call this sequence, we're going to do our sequence and we're going to take away 3n squared from it. So basically what I'm doing is I'm going to do 9 take away 3, which is 6, 22 take away 12, which is 10, 41 take away 27, which is 14, and I'm just going to keep subtracting them. Now you might notice that we've got a linear sequence now. This linear sequence that's formed is going up in 4s. So each one is going up in 4s. And we find the nth term of this linear sequence. So we're going to have 4n, and then we're going to work out what the 0th one is. I've not left myself very much room, and that's going to be 2. So our 0th term is going to be 2, so we know it's going to be 4n plus 2. So we put this bit here with this bit here, and that gives us our nth term of this quadratic sequence. So it's 3n squared plus 4n plus 2, and that's our answer. Now you can check this out by putting in 1 and putting in 2 and putting in 3 and seeing whether you do get 9, 22 and 41, which you will do. Okay, so to answer this question, we're going to have to first of all find the length of this diagonal here, and then when we've got that, the angle GEC is this angle here. So I'm going to call the length x, and I'm going to call the angle we're trying to find y. And I'm going to draw them out first, so I've got a better idea of what's going on. So I'm going to draw out triangle EGH first. So E, H, and G. And we've got 4 centimeters there, 5 centimeters there, and we've got X there. Then I'm going to draw out the other triangle, which is triangle CEG. C there, E and G. And we've called this one Y, we've called this one X, and the height of it is 6 centimeters. Okay, so we're going to use Pythagoras Theorem, which if you don't know how to use it, there's loads of stuff on the site to work out what X is, which could be root 4 squared plus 5 squared. 4 squared is 16, 5 squared is 25, so when you add them together it's 41, so that's root 41. I'm just going to leave it as root 41. So if x is root 41, we can put in x here as root 41. And we're going to use trigonometry. Again, if you don't know how to use trigonometry, there's loads of stuff on the site. And so what is it going to be? Tan y equals the opposite, which is 6 over root 41. So y equals the inverse tan of 6 over root 41. I'm going to do that on my calculator. Inverse tan fraction button 6 over root 41, close brackets, and I get 43.14 when it's rounded. So it's 43.14. And last thing is just to check that that kind of makes sense. Yeah, we're looking, all the values are roughly the same, 4, 5 and 6. So we're looking for it to be about that.
Well, I hope you found that video useful. If you did, please click like. If you want to see more from us, including the other 2 papers, please click subscribe. We've got loads and loads of stuff on the website on maths.com, which you can go to here, which is completely free. But if you feel you're quite far behind in the maths, or you're not happy with the grades you're getting on maths.com or other mock papers you have, you can try out our premium service, which is mathseffect.co.uk. With mathseffect.co.uk, it's a small monthly fee, and you can do an annual subscription, but if you only want to do it up until November, which makes sense, you can just pay per month. And what it does is it has the whole of the Maths GCSE as a journey, and you go through each topic, mastering it one topic at a time. A lot of the students I talk to say, I really don't know where to start. Like, I keep doing Pythagoras and trigonometry over and over again, and I don't really know what else I don't know. This is a service which just covers everything. It makes sure you master and you are an expert in every topic in maths. So it's worth checking out. Loads of people have joined already, and if you haven't joined, go to the website mathseffect.co.uk or click the link in the description. That will take you straight there and you can check it out. Otherwise, thank you very much. If you want to leave a comment down below of anything you want us to cover, because we're desperate to help anyone who's being caught up in this terrible situation, which is not ideal for anyone, but equally, like, we all understand why it's happened. But if I was having to resit or having to sit for the first time in November, I would feel exactly the same as you are probably feeling. So if you want to leave any comments down below, and we might release some videos just discussing options that you have open, or whatever it might be. Otherwise, thank you very much, and I'll see you in the next video.